immune system started to recognize the brain tissues in her ovaries and attacked it. The immune system started to cause inflammation and made antibodies against the brain tissue. The same antibodies then also traveled through the bloodstream to her head, where they attacked the brain. And
sometimes we experience weird feelings or aches and pains, and it could just be a headache, it could be we sprained something, it could be a bruise, it could be a number of things, something we twisted. There's different injuries or different developments of things that shouldn't be in our bodies that happen to us. Some of them are anomalous and some of them are pretty common. Today I want to look into an incident where a woman, she developed some type of brain in her stomach or in her abdominal area. It's a really weird story. So I'm not going to ramble on too much. Without further ado.
Have a headache. There might be different reasons why we have a headache. We might be stressed, have the flu, or simply drank too much alcohol the night before. But there might also be other reasons. For example, having a hairy brain growing in your body. Teratoma is a rare form of cancer that roughly occurs in 10,000 people worldwide every year. The name teratoma derives from the Greek word teros, or monster, and the suffix oma, which means tumor. Monstrous tumor. Curious name, right? The reason why teratoma is called teratoma is that it often contains different structures such as teeth, bones, or brain tissue. And don't Google it in case you do not want to be traumatized. Instead, I can draw it for you. Yeah, disgusting. Compared to all other forms of tumors where often only one cell type behaves abnormally, teratomas contain many different cell types where they shouldn't belong. So, how do they arise? Teratomas are the result of a mistake in our development. When an egg cell becomes fertilized, it slowly develops into an embryo. In this period, we find so-called pluripotent stem cells. Pluripotent stem cells can make more and more stem cells, helping the embryo to grow. They can further also become all kinds of cell types we find in the body. Brain cells, muscle cells, immune cells, you name it. And this is why we call them pluripotent. They can give rise to nearly all cell types we find in the body. And we find these stem cells only early in development. Stem cells later in life, which we find in the adult body, and we've covered them in the past, only can make a subset of different cell types. So while blood-forming stem cells in our bone marrow can only make the components of our blood, pluripotent stem cells can make nearly every cell type we find in the body. Embryonic stem cells normally work very well, otherwise we wouldn't be here and we wouldn't all look similar. But sometimes stuff can go wrong. Primordial germ cells are cells in our early development which can make egg cells or sperm. Primordial germ cells have to migrate to a very specific location in the embryo. If that works, everything is normal. But if these cells do not migrate to the right location, they might escalate and make all kinds of different cells. And this is how scientists believe many teratomas arise. Teratoma can theoretically...
So from what I'm gathering here, when this woman, they're gonna show her later, I guess when she was developing or becoming an adult, those cells didn't migrate to the correct area. This is what I'm gathering in short form. I'm trying to surmise what he just said, which is makes pretty interesting. I wonder what, I guess I missed it, how that starts. If they migrate to the correct area, then it's fine. I wonder what would cause them to migrate to the wrong area. Maybe they'll get into it, or maybe I missed it, who knows.
Occur everywhere in the body, but they are mostly found in the ovaries, the testes, the tongue, the neck, or even the brain. Teratoma mostly discovered during infancy or childhood, but sometimes they remain undetected for years. Take the case of a young woman. Let's call her CT. CT is a woman who likes to do all kinds of different activities. One day though, she awoke with a headache. She didn't think too much of it, as she often suffered from migraines. But there was something odd this time. One side of her brain felt numb. When her conditions didn't improve over the following days, she went to the hospital. The doctors prescribed her some medication and sent her home. She probably ate something bad before. But this wasn't the case. Her headache continued and continued. She went to the hospital again, but she didn't get a proper diagnosis. She was tested for viruses or bacteria and nothing. She was tested.
Yeah, I find this also is an issue. I know doctors have to look at you, and time is a factor in this. But with a lot of us, sometimes we go to the doctor or a physician or the hospital and we're given the wrong diagnosis initially. And to me, we've all had people or heard of people this happens to, and it seems to me it happens too often, more than not. And I always wonder what can be done to change that. I guess people need more tests. I think it's just that sometimes you spend a lot of time at the initial phase of diagnosing what's wrong with you, right? And instead of being referred, depends. Some doctors, they take a while to refer you. I guess they want to make sure they cover all their bases before they refer someone. I mean, I get it, but I don't know. Just something that I was thinking about.
For autoimmune disorders or cancer, nothing. In the meantime, her headache became unbearable. Her heart was beating rapidly and she couldn't think straight anymore. Then she had a seizure, and another, and she fell into a coma. All stories in the hero, and here's ours today. One doctor knew about teratomas, and he theorized that CT might have one. So he tested the blood and found unusual proteins, which are normally only found in early developments. This verified his theory. When her ovaries were scanned, they indeed found a teratoma. You might now ask, how does a teratoma in the hips explain a headache in the brain? You see, teratoma contain underdeveloped weird tissues. In CT's case, it contained brain tissue. And for a long time, this wasn't an issue. But then, for an unknown reason, her immune system started to recognize the brain tissues in her ovaries and attacked it. The immune system started to cause inflammation and made antibodies against the brain tissue. The same antibodies then also traveled through the bloodstream to her head, where they attacked the brain. And this was the ultimate cause for her headache and her seizures later on.
That makes sense, but that's like really scary. And I guess it happens a lot where your immune system attacks your body because something is abnormal, something abnormally develops, and then it creates those antibodies for that, and then whatever develops, it still carries your DNA. And I guess the DNA in her brain looks familiar to the brain tissue in her hips. So yeah, that's pretty scary. Let's see how they fixed it.
Fortunately, CT's teratoma could be surgically removed. There was no metastasis, and the attacking antibodies could also be treated through medication. It took her several weeks to recover, but in the end, she could walk home and live her life normally. Teratomas are something we do not want to encounter in our lives. They look horrific and...
No kidding. Yeah, even the little picture I saw, it looks disgusting. I'm not going to Google it. Some of you who are brave enough, shout out to my 3 returning viewers who are brave enough to look, can look at it and let us know.
Some cases can be life-threatening, but teratomas also have been important for science. The teratoma assay has been especially crucial in stem cell biology. In order to make a teratoma, a stem cell has to be capable of making brain cells, muscle cells, and many other types of cells. Not every stem cell can do that. In fact, only pluripotent stem cells found in early development can give rise to so many different cell types. In a teratoma assay, we transplant cells into mice to see if they can make a teratoma. If they can, then we have verified that they are pluripotent stem cells. Okay, but how does this help us? How does an assay which only detects pluripotent stem cells in early development, how is it actually useful for us? Have scientists forgotten what they put into the paper dishes? Well, no. The teratoma assay has been involved in many important studies, including one Nobel Prize study. In 2006, stem cell biology was changed forever in Japan. Shinya Yamanaka and Katsutoshi Takahashi knew that stem cells in their embryo can go on and become all kinds of different cells. They now try to find out though if we also can go the other way. Can, for example, skin cells transform back into a pluripotent stem cell? In order to answer this question, scientists started to activate embryonic genes in skin cells. Embryonic genes are only active in early development, and they give embryonic stem cells their identity. By activating embryonic genes in skin cells, the scientists try to find out if they can change the identity of the skin cell back into the identity.
This is an awesome theory, by the way. Basically changing the cell back to the original state. I forgot what he called it. Plural cells? I couldn't understand his pronunciation of that. Plume cells? Anyway, I'll maybe when I put on captions on the video, it will be spelled correctly. But yeah, that's really interesting, the way, that theory that they came up with.
Of an embryonic stem cell. For a long time, not much happened. But after activating 4 different genes at the same time, they saw that the cells started to look different. They didn't look like skin cells anymore, but more like embryonic stem cells. They called these cells induced pluripotent stem cell.
Okay, I guess that's what I meant. Pluripotent stem cells, or pluripotent cells. Okay, that's a good idea, and it looks like it's working. So you basically return the cell back to its pluripotent form.
In order to prove whether these induced pluripotent stem cells are really pluripotent, they transplanted them into mice. After a while, the induced pluripotent stem cells formed teratoma. Now they knew that they have just created stem cells from skin cells. Teratoma?
Why is he showing lightning like this is some mad scientist experiment? The physicists can't. This is great for. I think it's great for all types of healing, right? You take some cells from your body, you turn them back into stem cells, and you can pretty much heal yourself. I guess in theory, or you can give it to someone who knows how to grow them, and they grow your stem cells for you, and you freeze them. And if you need them for any type of recovery or any type of healing solution, then you have your stem cells in a bank. This is an idea, because I saw before they offered a service of keeping the stem cells from your umbilical cord, but this is an idea to me. This is great breakthrough.
Are now a bit out of fashion since they are a bit unstructured and chaotic. But what if we can control the development of embryonic stem cells, which otherwise would make teratoma? Instead of having a mass of different cell types like we have in teratoma, we can try to only create certain tissues or even whole organs in the laboratory. This is what scientists try to do right now. We can cultivate induced pluripotent stem cells in a petri dish, and after a while we add certain molecules which are found in early development. In this way, the stem cells get signals to develop in a controlled fashion and makes parts of the bodies we want. To this date, a lot of different cell types have been grown from induced pluripotent stem cells, and these include brain cells, immune cells, muscle cells, skin cells, and so on. It gets even more interesting though, if we try to make whole tissues or organs. Organoids are three-dimensional organ-like structures which are grown in the laboratory. Also here we add and remove.
I remember making a previous video regarding organoids they made in a petri dish. They grew brain cells, and they made the brain cells play the video game Pong. Several videos back I made that, so I think going forward here it'll be a good idea if they could grow organs. I think this would save, well, depending on how fast they could grow the organs for yourself, right? If you need another organ, they grow your organ. I don't know how long that takes. Maybe they'll tell us, and instead of taking a transplant, they grow your new organ, and hopefully your body doesn't reject its own cells.
But molecules to stem cells. But this time we control even more parameters to not only make specific cell types but whole tissues. Organoids have been grown to mimic most parts of the body, and they already helped us in the past. In 2015, a mysterious outbreak occurred in Brazil. Thousands of infants were born with a condition called microcephaly. In this case, the brain is underdeveloped and the head is smaller than usual. Scientists tried to find the cause of the disease, and they suspected the Zika virus to be the culprit. So the question now is, how could we test such a theory? We cannot really infect any infants or developing embryos.
I've seen that before, where that Zika virus did cause a funny look to certain people, and it showed how they looked as they became adults.
To find out if they get microcephaly. So instead they infected brain organoids with the Zika virus. Brain organoids mimic the developing brain, and if the Zika virus leads to brain damages, it should also affect brain organoids. They quickly observed that infected brain organoids cannot grow properly anymore, which proved their theory and helped to contain the outbreak. But of course this is not the only application of organoids. Kidney organoids, meaning
Yeah, I'm gonna stop right there. I did have a previous video regarding brain organoids and things like that. It's a very interesting topic, and there's just it seems like a million applications you could use for that. I'm gonna stop right here, and I appreciate your time. If you made it this far, thank you so much, and please don't forget to like and subscribe.